Okay, hi guys. So in this lecture, we'll be continuing uh, our set of examples from the previous lecture. Okay, so in that we need to find how many moles of Grignard reagent would be used in the following compounds. Okay, so let us continue. We had a new example as this OH here and this here. So how many moles would be used here? Uh, two CS3s can be used here directly for removing this group and this group. So 2, and then again one would be used to finally have a alcohol group on the this carbon atom. Okay, so 2 plus 1 here and 1 would be required here, so total 4. Okay, let us see another example. We have something like this here, and we have Cl here, Cl here as well, and then we have something like this here. So how many moles would be used here? So CS3 minus can actually have CS3 minus can be used as a nucleophile on this case. Okay, so CS3 minus can be used as a nucleophile here to substitute this carbon, this Cl. Okay, obviously this cannot be used here because of the formation of our highly unstable aryl cation. Okay, so then obviously we can use one CS3 minus in the epoxide ring as well. Okay, because of the presence of high ring strain, so this will also be having a high ring strain and a positive charge, partial positive charge on this carbon, so it can attack on this carbon. Okay, so total 2 moles can be used here. Okay, let's look at another example. We have something like this and this and this here. Okay, so how many moles of Grignard reagent can be used here? 2 here. Okay, one would be to remove this and another would be to form a alcohol group on this on this oxygen atom. Okay, or yeah, so now on this oxygen atom. Okay, so 2 here and obviously 1 here. Okay, so total 3. We would have, now we have something like this where we have this epoxide ring, so obviously 1 can be used here to break the bond between C and O so that it can reduce the 3-member ring strain and as well as partial positive character on this carbon atom. So 1 can be used here. Let's look at 5th example. We have something like this. Okay, and for this actually we had ring strain in this case, but in this case no ring strain is there, hence it would be requiring 0 Grignard reagent moles. Okay, now let's look at another example. We have something like this. Okay, and CH2Cl on meta position of aniline, so this is Cl here. So in this case how many moles of RmGbr can be used? Obviously one would be to substitute on Cl from this carbon atom, and another would be on this nitrogen atom. Why? And obviously why? Because NH2 would also can behave as an acid in this case. Why? Because if you look at the reaction here, we'll get something like CH3 minus will be attacking here, and finally this would be RNH minus here and CH4 here. So if you look at the acidic strength of NH2 and CH4, you will see that NH2 is is having better acidic strength than CH4. Or you can simply look at like this as well, that which is more stable, negative charge on more electronegative element or negative charge on less electronegative element. Obviously this would be more stable, hence this reaction would go into the forward direction. Okay, but as soon as this formed and as soon as CH3 minus acts as a nucleophile, in this case the Grignard agent would be removed from the reaction, and again H plus would be involved in the reaction. So in this case again the answer would be 2. Okay, so with this we come to the end of this lecture. In the next lecture as well we will be seeing some more examples on the same. Till then, good luck and goodbye.